So let's just take a quick look at how to generate a randomization distribution for one proportion for the Vietnam War draft example in Statkey. We're going to Statkey now, and we're going to look under test for one proportion, or we're going to look for test for one proportion under the title Randomization Hypothesis Tests. And when we get there, the first thing we're going to do is click on the Edit Data button and enter these values. Our count is 25 and our sample size is 194. So let's go ahead and do that. Under Randomization Hypothesis Tests over here on the right, you can see Test for Single Proportion. This is where we'll start. The Edit Data button near the top is where we enter our count of 25 and our sample size of 194. And we can see that over here under Original Sample, that now shows the numbers we just entered, and it shows our sample proportion of 0.129. So the next thing we need to do is get the null hypothesis correct. It starts with p equals 0.5, that's the default null hypothesis. If you were asking a question about, say for example, whether or not a coin was a fair coin, then you would be comparing the proportion of heads to 0.5. So that's the most standard sort of default case. We don't want that to be 0.5 in this case. Recall that our null parameter was p equals 0.085. This is the proportion of December birthdays that we would expect to see if all of the dates were mixed properly in the jar. That's where that null proportion comes from. So I'm going to click here where it says null hypothesis p equals and change that value to 0.085. Now I have all of the information entered that I need, so I can go ahead and generate a few thousand samples, and then I'll click on right tail because we want a right tail probability. And this endpoint here by default, this 0.124 that we see, by default it is what gives us 2.5% in the tail. So just like with the bootstrap distributions, with these randomization distributions, when you first select a tail, it's going to default to the center 95% and 2.5% in each tail. But that's not what we want. We want that boundary value to be our sample statistic, 0.129. So I touch the 0.124 and overwrite it with 0.129, and then I get my p-value as the number or the proportion of dots in that tail, which is written above here where it says 0.12. So my p-value from Statkey is 0.012. You might have a slightly different p-value in yours. And incidentally, you will see a little bit more variation from one person's graph to another's when you're doing proportions. Because if we look at this graph, we can see there's a lot of space in between these bars. When we're simulating possible proportions, there's only certain values that tend to come out. If I reset and generate again, let's go ahead and see if I get the same p-value. It looks like I probably will get pretty close. 0.0095, so it is a little off. If I keep generating samples, then it's going to get closer to that 0.012. Just remember that the values that we want to enter on this dot plot once we get it are our sample statistic. So this is the one that we overwrite. And then this gives us our p-value. So our p-value in this graph comes out to be 0.013. Pretty close to the 1% that we calculated from our graph with not quite as many samples generated. We first did this from a graph with only 100 samples, so we couldn't get quite as much precision in our estimate.